This morning's next speaker is Dave Steinhoff, who's worked at radio communications for almost 2 decades. He started his career at Western Technical School in Wisconsin and graduated from the electronic servicing program. In 2002, Dave started with Communications Service, a Motorola dealer with shops in Madison, Portage, and La Crosse, Wisconsin. And in 2008, Dave became service manager for La Crosse. Presently, Dave serves as the engineering manager for Baycom, which Communications Service merged with in 2017. During his 16 years in radio communications, Dave has installed and optimized 5 countywide simulcast radio systems. Dave will be sharing his information on their success in implementing simulcast in small cities. Please welcome Dave.
Okay, as Ed said, my name is Dave. I'm going to correct his enunciation of Steinhoff, not Steinhoff, German. But I do work for Baycom, and simulcast deployments for small cities is the place we're going at. So just a little background on, again, Communications Service Baycom. So Communications Service originally had offices in La Crosse, Portage, and Madison, Wisconsin. It merged with Baycom, which then Baycom had offices in Green Bay, Fox Crossing, and Pewaukee. And again, the joining of the two pretty much covers most of the state of Wisconsin. So what I'm going to cover today is suppliers that we use for these systems. I'm going to cover a couple of the systems that we have deployed in the city of Toma and the city of Wisconsin Rapids for Wisconsin. Okay, suppliers. So in the system, we are utilizing the Motorola GTR 8000 transceiver and the MLC 8000 analog simulcast timing and voting. The backhaul that we utilize in most of these systems is the XXII 4.9 microwave and the Radwin 4.0 microwave. And it says with licensing, we'll cover that a little bit as far as what that means. The Spectracom Secure Sync GPS is used for the timing. And for any filtering, we're using the Bird TX RX filtering and duplexing. Switches, networking equipment that's used, it's mainly just simple switches in these kinds of small systems that we're utilizing. They can be managed and non-managed. The gear shift has been more towards the managed side for these. The MLC 8000 for Motorola, so this is the simulcast control unit. The single device can serve as both the voter controller unit as well as can be reprogrammed to serve as the analog gateway unit that talks to the transceiver. So within the controlling unit, the voting unit, the launch values, the amplitudes for modulation, PL, DPL, and the amplitude for the PL, DPL is all controlled within that one box. The Motorola GTR 8000 is the transceiver that we're utilizing. It can do analog FM, P25, phase 1, phase 2 digital, and it is backwards compatible with the Quantar. However, in a simulcast system, you cannot mix the Quantar with the GTR in the same channel. The Spectracom. So the Spectracom Secure Sync is the GPS that we're utilizing. The biggest thing that it has some great modular design and flexibility. Different option cards can be installed in it depending on the need of the system. And the particular unit that's shown on there has the typical setup that we use, which is a 4-port card that usually has enough outputs to connect all the devices that are in these smaller systems. Does have an option for 120 volt AC and or 48 volts, so it can accommodate anything that has the 48 volt with microwave and whatnot. So the IP microwave, the backhaul. So I'm going to start at the bottom of the slide and work way up. So the XXII 4.9 was the first choice that we're using in these small systems. Part of the reason is we were converting over from a T1 type system into IP, and this particular box did both. It's an all indoor unit. It had no hot standby options, However, it is no longer sold by XXII. So the next unit that we started using was the Radwin XXII. Again, it's 4.9, it's all indoor, no hot standby option again. And as mentioned before, the 4.9 is what we like to call license on license. You have to license it through the FCC website, but there's no coordination that it goes through like a normal microwave. But it does get licensed so you can check online who's using what frequencies and make sure there's no overlap there. The only note that we have on these indoor units, Baycom prefers to use the indoor units, and that's just so that if a tech has to go out and repair the unit, they don't have to have a tower crew climb up onto the tower to take care of any tower top applications. And then as far as the setup of the backhaul, we like to use separate VLANs for the radio traffic in comparison to all the other traffic that's used. So that way you have focused bandwidth for the radio traffic, and then management type traffic flows on a different VLAN. And we can keep those two separate to prevent any sort of interference on the voice side of the network.
If I can interrupt, so are you telling us that in the programming you're able to create, if you will, committed information rate for the radio VLAN?
As far as like a bandwidth control for each VLAN,
Yes.
I would have to check if that, and get back to you, if the actual product can limit the bandwidth for each. I don't remember offhand.
Okay, thank you.
So in the case of using the IP backhaul, if you do have a need for running a non-simulcasted audio through it, the solution that we found is the NetExpress from Gates Air. So in this scenario that's played out here, we have a prime site where the council priority input is at a different site from where the council location is. So in this case, we need to get that audio up there, but it's not going to funnel through the IP simulcast system. So we utilize the 4-wire circuits that exist, pipe it through the backhaul, IP backhaul, and then back out to the actual prime site where the council priority takes place. Okay, so I'm going to gear shift now. Those were the suppliers, and jump into the first city that this was deployed in, the city of Toma in Wisconsin. As noted there, it is the Cranberry Country. And the city of Toma is a small city. It's less than 10,000 in population, reasonably flat terrain, and it has a dedicated police department dispatched on its own channel. Again, it's located in Monroe County in Wisconsin. So the issue was that the indoor coverage became a problem. They had a single site that was located at the police department, and the steps that we took to try to improve the coverage over time was to add a voting site to that particular system. And then by adding that, we did have some downlink problems indoors. And then we also had an unbalanced uplink downlink depending on location because of 2 receivers but only 1 transmitter in the system. So the solution that we landed on in the end is to expand from the single site transmit to 3 sites in total for transmit. And the project overlapped when the XXII microwave was canceled from that particular manufacturer. So we have both XXII and Radwin in this particular system. The other thing that we did try to do is we tried to utilize some wire line that existed between 2 sites where the old voting system took place. So we tried some DSL modem, private DSL modem type situation. That was not successful, so again the microwave was used in its place. And all 3 sites are used for simulcast and voted. And the GTR 8000 MLT 8000 is used. On the network side, there are no routers involved. There's just simple switches that are used, managed switches. And again, the GPS that we're using for the timing is the Spectracom. So this is the drawing of the city map that Toma PD kind of lands, and the single site is drawn on the map right now. So again, what we did is we took that and we applied 2 more sites to it. And what we'll do now is we'll go into the coverage maps that are developed from those sites. So this is the talkback from portables, and it's shown for the single site coverage that the system started at. And the color coding that's on the screen is much like a stoplight. So you start with the gray in the center, which is the throwing signal. And you get into the dark green and light green, which is excellent, good portable coverage. And then when you start getting into yellow, you're in the marginal coverage, and then red is no portable coverage. So again, much like a stoplight as you look at these drawings. So the next slide here is the 3 sites. Again, talk back coverage from the portables. I'm just going to flop back and forth so you can see the kind of differences that are experienced. So it increased coverage vastly for indoor coverage for the particular city within the city boundaries there. The other map here is the talk out coverage to the portables. And again, single site shown first, same color coding scheme. So stoplight, think red, no go, yellow, marginal, and then the green's good. And that was the single site and the 3 sites added in. And again, just a quick reference to the differences between it going back and forth here. So once again, a significant improvement of coverage across the city boundary area that was required for them for indoor coverage. All right, City of Wisconsin Rapids, once again in Wisconsin. And similar terrain as far as the city goes, population of a little less than 20,000 in this case. And once again, a dedicated police department on their own channel. And this one is in Wood County, Wisconsin. Indoor coverage was the biggest problem once again. And an issue that was driving that was they had only a single site, and the site was not centrally located. We'll see that on the map next. So the solution, once again, was to go from a single site to 2 sites. In this case, it's using the Radwin microwave for both the link that's going in. It is simulcast transmit and voted from both sites. And a 3rd site may be added depending on what they see for coverage for indoor with the initial deployment of the 2 sites. GTR 8000, MLC 8000, again, no routers, simple network system, and Spectracom GPS as well. So coverage maps, again, same color code. So this is the single site, and you can note how far off-centered from the city boundaries that the single site was. They had a lot of spare coverage going from the south to the north. And then the 2nd site being added, giving them, again, a good coverage. And then depending on if they wanted to shift to a 3rd site, we already had it mapped out, but that's what a 3rd site would do in this case to give them more expanded coverage, more indoors, depending on the type of coverage they get from the first 2 sites. All right, summary. So the big driver for this is to provide the indoor coverage for these small systems. And downlink, simulcast transmit for coverage on the downlink side. The uplink side is covered by the voting receivers. And typical site spacing that we see is about 1 to 2 minutes. 1 to 2 miles. Because of the close site spacing, we don't use any launch timing offsets. Again, the 1 to 2 miles is kind of the reason for that. And cost effective. So these systems, because main driver of the MLC 8000 and its cost point, these systems have become tremendously affordable for small cities. And again, that's the major driver for it. Another reason is the simple network structure that exists. You don't need fancy routers or anything like that, just simple flat IP networks are utilized to make these work. And utilizing the 4.9 microwave, again, a low cost point for that kind of system. And these kinds of systems then become affordable inside the city government budget. So some of the lessons learned, we talked about the Exalt microwave and the Radwin microwave. So getting 2 different microwave systems to be synchronized together is not something that's possible. So during that transition time period, we weren't able to deal with that across multiple manufacturers. Early on, it's the locking of the 4.9 frequency within the equipment. So because the equipment can do switching of frequencies depending on if it sees interference or not, that is not a good thing when you're trying to establish that dedicated point-to-point. So locking that into a single frequency is one of the items that we found. LED disruption light noises on a water tower. So in the case of the Toma PD system, one of the structures was a water tower. It had a light on there, And after troubleshooting the system for some issues on the inbound coverage from portables, we found that the LED obstruction light was actually causing noises. So as it was flashing every second, it was inducing a bunch of noise. That in turn caused a bunch of voting issues, as well as just signal issues from the portables. And frequency coordination. One of the things we're finding these days is that there's more letters of concurrence that we're needing when in the past it wasn't needed so much. So it seems that every time we're going out to get a frequency license for a microwave for a simulcast system, even though the frequency is already licensed within a mile or two, we're finding that licensing the second site is needing letters of concurrence when it doesn't seem like there should be a need for it. And then second thing, or last thing, is the additional sites to be added. So these systems can be developed over the budget cycle. So if you want to start with a 2 site, but they need to get to a 4, or they need to get to a 3, you can do a couple sites to start, and shift and add in a 3rd site to that next budget cycle. And that is the conclusion of my presentation. Thanks, everyone.